Hello, welcome to this video. We are going to talk about the quadratic function. And so for Math 3 students, this is a review on a very, very important type of function that you'll continue to see going forward, as well as on your state testing for SBAC if you are a junior. So today we're going to look at the four forms of a quadratic function, and specifically we're learning how to identify characteristics of a quadratic function using a particular form. The form of the quadratic function to identify the vertex and its maximum or minimum is very, very important. So hopefully you can identify and use that. And you can use the form of the quadratic function to identify zeros or x-intercepts as well as y-intercepts. And then additionally, if you can do that from a form, hopefully you should be able to do it visually through a graph of a quadratic function. So let's go ahead and refresh your memory on what a quadratic function is. Here is a quadratic function, and you can see some key points and topics that we have. We have zeros, also known as x-intercepts. So a zero is just the x value, so like this zero would be -1, whereas the x-intercept is an ordered pair, an x comma y. So this would be -1 comma 0. And we can also see that here with this one. The y-intercept is always an intercept. It's always an ordered pair. So that one is going to be 0, -6. So 0 comma the y value. Your x value is always 0 for those. And then we also have this key point for a parabola, which is the vertex. And the vertex is the center of the graph, as the graph is symmetrical around this vertical line that runs through the vertex. And it will also be a minimum or a maximum based upon the direction that the graph is opening. Is it opening up or is it opening down? Now, a normal parabola does open up. The vertex is a minimum if your a value, again, where your a value is the multiplier in front, if that's positive, your graph is opening up. If it is a negative, if this a value is negative, then that's going to be a maximum because you're going to have reflection. Your graph's going to open down. The other important part of this is the vertex. Again, is the vertex. I guess maybe let me just do this so that makes sense. I guess I can. Well, I don't know. It's fine. Is that your vertex is h comma k. This is going to be the location of your vertex. Normally, the parent graph of a parabola is at 0, 0. So if I plug in 0, I get 0 squared, which is at the origin, but we can move this graph. So in this example, we would have a vertex, which is at 1 comma -8. It would have an h value of 1 and a k value of -8. Okay, so that's vertex form. We like vertex form the most because I feel like it conveys the most. However, if I'm trying to find intercepts or zeros, we like standard form. Standard form is pretty awesome because standard form will give you a constant or an initial value. So if I plug in 0 for all of my f of x values, f of 0, what we end up getting is just c. We just get this constant. So we like that as well. And then lastly, factored form. Factored form is the best for finding the zeros because if it's factored, I can just set each of these factors equal to 0 and then I can solve. So a factor of x minus d, this would give us the 0 of d, and x minus f, this would give us a 0 of f. Okay, and we'll kind of see that here. So let's go ahead. That's the concept and the idea. Let's jump into some practice problems. So example 1, using the given quadratic function, find the coordinates of the vertex and state whether the vertex is a maximum or a minimum. Okay, so what we're going to do here is, again, identify our h. I guess maybe our a value too. Our a value is important. Is 1, h is -3 because it's always the opposite. I almost got caught. And then your k value here is -8. So this means that our vertex will be h comma k, -3 comma -8. There you go. Now it's also important to know that this is a vertex, is a minimum. And why is it minimum? Because our a value is positive. It is positive. So it's normal. I'm not having any reflection. Let's look at example 2. Example 2, my a value is -3. So that means I'm going to have reflection. now my vertex is going to be a maximum because that's less than 0. So I'll write that here in a second. H value is a positive 5. Again, it's always the opposite. And K here is 1. So the vertex is 5, 1. Because that's H, comma K. And the vertex is a maximum because A is negative. It is less than 0. Okay? All right. Go ahead. Pause the video. I want you to try these 2 practice problems. All right, let's go ahead and look at the first practice problem. Here, hopefully you got the vertex is 6, negative 4, and it is a maximum because your A value is less than 0. H is 6, K is negative 4. So this vertex form here, this tells us our center of our graph, 6, negative 4. And I know that this is going to be a maximum. It's downward facing because of that negative, that leading negative. Okay, go ahead, pause the video, and I'll show you the answers to the second practice problem here in a second. All right, for practice problem 2, the vertex is negative 1, 9, and it's a minimum because my A value is positive. This is a normal upward facing parabola. It doesn't matter that it's 2, it's positive, so we're still opening upwards, and we're shifted left 1 and up 9. So that's your vertex, okay? All right, hopefully you got those right. Let's look at a couple practice questions here. So in multiple choice form. Which of the following is true about the vertex of the function f of x equals negative x plus 4 to the power 2 minus 3? What is the vertex, and is it a minimum or a maximum? Pause me. I'll reveal the answer here in a second. All right, hopefully you tried this one, and what you got is an A value of negative 1, an H value of negative 4, and a K value of negative 3. What this problem will really test you on is, one, do you understand that your H value is always the opposite? So you'll notice C and D, they have an H value here that is a positive 4. That's completely wrong. So we can throw those answers out. So it's between A and B. And then the other part is this a minimum or is it a maximum? So based upon my A value that is negative, my parabola is going to be downward facing. So that will make this a maximum. Correct answer? B. B. Did you get it? Good job. All right. Here is the next question here. It says, which equation reveals the minimum or maximum of f of x without changing the form of the equation? So which of these can we look at? It says, hey, there's the min and the max. Think about this one, come up with an answer, and I'll show you an answer here in a second. All right, the form that gives us the minimum or the maximum is the one that shows us the vertex. So what I need to find is I need to find which one has vertex form. And so that's going to be B. Hopefully you selected B. That's the one that it's looked like. D, this is, actually, sorry, I'll start with C. C is standard form. C is standard form, and this is useful for identifying our y-intercept, which would be -6. And then D is also standard, but it's with a GCF. Okay, so that one's not too common. And then A, this is factored form, so that is useful for are zeros. Okay, so B, that's the one that gives you your center point of the graph, your vertex, which is a min or a max, B. Okay, let's go ahead and move on. Now we're going to move on to standard form. And standard form, you'll notice, is just a group of terms, usually a trinomial in decreasing order, right? So power 2, power 1, and then a constant. So these are in standard form, and we say, which of the following functions, what is the y-intercept of them? So the way that you find a y-intercept, it's very important that you understand that a y-intercept has the coordinate always 0, y, right? If I'm graphing this on a y-axis, here is my y-intercept, this location, 0, whatever that y value is. And so the key feature here is that the x value of a y-intercept is always 0. So I can easily find it if I plug in 0. What's f of 0? So 2 times 0 squared minus 3 times 0 plus 7. And the great thing about polynomials is when you evaluate at 0, anything that's multiplying with a variable disappears. So this really simplifies to 7. So our y-intercept is going to be 0, 7. And that's why standard form is really great, because you can identify your y-intercept. Okay, so let me evaluate at 0. These disappear. Answer 7. Let's look at example with g of x. G of x is negative x squared plus 9x minus 4. What's the y-intercept? Well, if I plug in 0, this is going to go to 0. This is going to go to 0, and I get negative 4. So g of 0 is negative 4. Therefore, our y-intercept is negative 4. Pretty straightforward. Go ahead. I don't think you need to pause me too long. Try this practice problem here. What do you get for the y-intercept? Did you do it? You're done? You did it? Good. Hopefully you got 3. 0, 3. That's your y-intercept, because h of 0, if we plug this in, we get 0 squared, which is 0, plus 2 times 0, which is 0, plus 3, which gives us 3. Pretty straightforward. Awesome. Okay, same idea on this multiple choice question. It says, given the function f of x, which is x minus 4 times x plus 7, which other form of the equation is correctly matched with the key feature of the graph to represent, of the function it represents? So we have some situations here where we see a standard form, and it says it highlights the y-intercept, highlights the x-intercept. So what is it? Try this one. I'll show you the answer here in a second. So a little tricky on this one. What I want you to know that in the answers, all of these are in standard form. So again, from this format, we can easily see the y-intercept. So I'm not going to highlight C or D. These forms do not tell me the y-intercept. This form up here, F, this shows me some zeros and some x-intercepts. We'll get into that in a second. But standard form shows the y-intercept, and it's going to be the constant value, which is negative 28. It's the initial value. Answer here is A. Hopefully you got it. Okay, last topic here, zeros. Zeros of a quadratic function. If I have a function, a quadratic function, say here that this is factored, right? This will be factored from standard form. It would look like this. Like this. And I have factored form. Can I identify the zeros? Well, you get the zeros when you set something equal to 0. And if I have, let's say, an expression, a times b is equal to 0. Well, one of two things has to be true, or both. Is that either a is 0, right? That would make this outcome 0. A times b gives us 0. Or b is equal to 0. So we call this the zero product property. And the zero product property allows us to solve factored polynomials and set them equal to 0 and find an answer. So x plus 5, if I set this equal to 0, and I go ahead and move this 5 over, I'm going to subtract 5, I get x is equal to negative 5. And I can do the same with x minus 6. Set that equal to 0. Let's add a 6 to both sides. We get x equals 6. So here's our zeros. Negative 5 and 6. And usually students catch on pretty quick that the opposite value of whatever you see is the 0. So if I set this equal to 0, hey, 1 0 is negative 5. Here, 1 0 is 6. It's always the opposite, like the h value. And hopefully you see almost kind of like that h component. So let's look at example number 2 here. G of x equals 2 times x minus 3 times x plus 7. What are the zeros? Again, I want to set this equal to 0. So I can set x minus 3 equal to 0. I can set x plus 7 equal to 0. And I get the opposite. So x is equal to 3, right? Because I added 3. Or, if I subtract 7 over here, x is negative 7. Okay? Now, before you jump all over me, what about the 2? What about the 2? What if I set 2 equal to 0? Is 2 ever equal to 0? No. This is a contradictory statement. 2 is never equal to 0, so we just ignore that 2. We don't do anything with it. We only care about the factors that have the x in it. Okay? All right, go ahead. Please try this one. Let's see what you get. Did you pause me? Hopefully you paused me. Here's the answer. Your zeros are going to be -1 and -4. That easy. You just set them equal to 0 and you solve, right? X plus 1 equals 0 gives us x equals -1. X plus 4 equals 0, x equals -4. Very easy peasies. All right. Next example. Go ahead, try this example. What are the zeros? You're like, I'm so quick with it. I know it's 8 and 2. Perfect. Perfect. 8 and 2. It's always the opposite sign here. Oh, what about the 1/2? Ignore it. It doesn't do anything for us in this case. Okay? All right. And then I think we have some multiple choice questions down here. Same question. This one's an example. Given f of x equals x squared minus 5x minus 14, which of these forms is correctly matched with the key feature of the graph of the function it represents? So notice all of these options, these are factored form. These are factored. And that's going to highlight, again, zeros. So, I have a couple of options. What you should notice, I just noticed this. Wow, this question's harder than I thought. Do you see how some of these signs are changed? So I'm going to have to determine proper factorization. So I'm going to look at this and say, hey, what's the proper factorization? Let's bring that back. I have a -14, so I need a 7 and a 2 that are opposite. And 7 and a 2, which all of these have. Okay, but what are the signs? Well, my 5 here in the middle is negative, so I want my bigger number to be negative. So I think -7 plus 2. So that's going to throw out B and C. Okay, and then what are the zeros that result from them? Are they -7 and 2? Well, those match exactly. That's not what we want. We want them to be opposite. The opposite, a +7, a -2. Okay. Please pause me, try this practice problem here. We are almost done. All right, hopefully you pause this one. Here is the solution. You need to go ahead and factor this polynomial first. So since I have a -24, my factors are going to be, what do I got? 6 and 4, I think, are my winners. And I want a +2, so it's going to be a +6 and a -4. So let's throw out A and B, and then my zeros switch. -6, +4. Answer is C. Answer is C. Okay. Last question. Pretty straightforward here. Given a graph, this is our last success criteria. Can you identify key features from a graph? Well, what are the zeros of this function? Right here. And right here. So what are those numbers? -3 and a +1. Now, a common error on the SBAC, do you guys see this wordage here? It says select all. Select all. So I have to select multiple or all the correct options, not just one. I have to select all of them. So there are 2 right answers here, so make sure you select all. Last practice problem here for the lesson. Please pause me and try this example. Okay, hopefully you paused me and you saw that we have zeros at 2 and 4. 2 and 4, so that's going to be A and C, not B or D. Okay, let's recap. In this lesson, we talked about different types of forms. We talked about vertex form, standard form, and factored form. Vertex form gives us the vertex. We're able to identify the vertex and if it's a maximum or minimum based upon the A value. Standard form gives us the y-intercept, where it crosses the y-axis, and that's because standard form highlights a constant value, so that's our initial value. Plug in 0, and we get C. Factored form gives us the zeros, because I can go ahead and not plug in 0, I don't plug it in, I set it equal to 0, and I solve, so we can get our zeros. All right, are you able to do these following things with these forms? Hopefully you are. Go ahead, give me a thumbs up, give me a follow. I'll catch you in the next video. See you later.